Hi folks, we're going to take a look at a couple of examples of finding powers of monomials. So if we take a look at this first example, we have a monomial inside the bracket because it's a product of powers and a number, which we call the coefficient, and it's all taken to the exponent of 3. Okay, so first thing to keep in mind is that this exponent applies to everything inside the bracket, all the powers and the coefficient. Okay, so one way to represent that, especially at the start, is you can use arrows to represent that you're distributing that exponent to each part of the monomial. Okay, now this step here is something that I hope you'll eventually not have to write, but you might want to do it at the beginning, again, to really understand the idea that this exponent applies to every single part of the monomial. So here what we're doing is we're taking 2 cubed, okay, and then we're taking x squared cubed, y to the 5th cubed, and z to the 6th cubed. Okay, and now from here we use our properties of exponents. So 2 cubed, 2 times 2 times 2 is just 8. Here we use the power of a power law. We know that when we have a power of a power, we multiply the exponents without changing the base. So x to the 6th, 5 times 3 is 15, so y to the 15, and 6 times 3 is 18, so z to the 18. Okay, and there's our final answer. Okay, let's take a look now at example 2. Now, the reason why I'm putting this example in is because of that negative in front of the number. Okay, now this is often a common mistake to forget about applying the power to the negative. Okay, and it will be important here because we know that when we square a negative number, we'll get something that's positive. Okay, so I'm going to follow the same idea here. I'm going to use my arrows to represent distributing that exponent to each part of the monomial. Okay, and now here I know that I'm taking negative 5 squared, so the whole number is being squared. Then similar to before, x to the 6th squared. Okay, now just going to stop here and make sure we realize that this exponent, because there's no brackets around this yz, this exponent only applies to the z. The exponent of y here, when we don't write an exponent, we just assume it's exponent 1. Okay, so this is going to be y squared and then z squared squared. Okay, so the reason why it was important to use the brackets here is because the whole number is being squared, so negative 5 times negative 5 now gives us positive 25. And then here, 6 times 2 is 12, again using the third exponent law. Here, 1 times 2 is 2. And 2 times 2 is 4. Okay? Now, had this been an odd power, had this been cubed, well, the coefficient would have remained negative, because when we multiply a negative number 3 times, it remains negative. Okay? So, just to recap, keep in mind that when you're doing a power of a monomial, you have to apply that power to every portion of the monomial, the coefficient and all the individual powers. Okay. Eventually, I'm hoping you should be able to go directly from the first step to the last step. Okay. But only start doing that once you get really confident and you stop making mistakes. Okay. That's it for now.